Okay, so they give us a nice picture, right? So what's the primary equation? And what's the quantity we're trying to maximize? Is it minimize or maximize?
Minimize.
Minimize.
Perimeter.
The perimeter, okay. So it's kind of like a perimeter, right? The fencing. So we'll just call it P. So what's P equal to?
2y plus x.
Okay. How many independent variables? 2. Okay, so what do I need a secondary equation.
So x area is y.
Ah, okay, we have an area, right? The area is given to us. Okay, remember, we're looking for, the secondary equation has to be a constraint, has to give us a number that limits us, and there's the number that limits us. So x, y equals 245,000, okay? In this case, does it make a big difference which one you solve for? Probably not. I mean, x would be a little bit easier maybe, right? So if we solve for x, what do we get? Just that number divided by y, right? So let's put a box around that. There's our substitution equation, okay? So then what does that make our primary equation?
That plus 2y.
Okay, that plus 2y. All right. So then we're going to end up with P of y, that's going to be our independent variable, equals that plus 2y. Well, what do we need to go with that? Domain, okay, good. So what about our domain? Are there any values of y that we have to mathematically disallow? 0, can't be 0, right? But that's the only place mathematically, the only number we couldn't have. But physically, what do you think?
Equal to or less than 0.
Can't go over.
You can't have anything equal or less than 0.
You can't have anything, so it's got to be greater than 0, right? Is there going to be an upper limit?
245,000.
That's, okay, is there? Now think about this. That's the area, right? Richard, you're shaking your head. What, talk to us.
Well, if it's over 245,000, that means the x is actually like really small, right?
Right, right. So you can look at this, think in terms of x, right? We know that y gets big as x gets small and vice versa, right? So when y is approaching 0, x is really big, right? Okay. What about when x gets really small? When x gets really small and approaches 0, what's that doing to y?
It's really big.
It's got to be approach what? Infinity. Yeah, and that makes sense if you think about it. Even if you took something like an area the size of a piece of paper, if we remove any physical restrictions on matter, and we just look at this mathematically, if the area of this page is fixed, if I cut the height in half, what's that do to the width? Doubles it, right? If I cut the height so it's only 1/1,000,000th as big as it was previously, it's 1,000,000 times bigger, but there's no restriction mathematically on how small I can make this, right? I could let the height approach 0, which means that the width would have to approach infinity to keep that area, right? Okay, so, I mean, it'd be like saying, what's a good, and this doesn't work in the real world because there are ultimately some small particles that limit the ability for us to push this limit to 0, but if you took a drop of some fluid and you smushed it out so it was infinitely thin, how big would the radius be? Infinite, theoretically. It doesn't work that way, but in principle, mathematically it does. So, everybody agrees that's our domain, and we have to exclude 0 because we have a y on the bottom? Okay? So now what? Yeah, now we're just shift into calculus mode and make a table. Right now we've sort of digested the problem here and turned it into a math problem, and now we can just focus on the math problem until we're done, and then we'll come back and interpret our results in the context of the problem. Okay, so what is P prime going to be then? So I'm going to get a 2 from this term, right? What about this one?
45,000 last year.
Okay, so it's, what I've really got here is a 245,000 y to the negative 1, right? What's the derivative of y to the negative 1? Negative
2.
y to the negative 2. Okay, so I'm going to end up with, everybody agree? Right, does that make sense? I took the negative 1 out front, and I turned the negative 1 exponent into a negative 2. So now it's on the bottom, right? Would it make sense to do a second derivative? I think it would,
Yeah,
right? All you need to know is what the sign's gonna be. So p double prime, we get 0, and then this is the same thing as saying negative some constant times y to the negative 2, right? So when right, so this is really just equal to 2 minus 245,000 y to the negative 2. When I differentiate, that goes away. What do I get from this other part? 490. So I get some big positive number times y to the negative 3, right? So I get a positive number over y cubed. I don't even really need to worry about what the number is, right? Because we just want to know the sign of the second derivative, right? What's it going to be on our domain? What's the sign of the second derivative going to always be? Positive, yeah. Okay? So I can make my table. Oh, and then, because we didn't find critical numbers, did we? So p prime equals 0 when what's true? When, I guess when that equals 2, right? So if I, well, let's write that down. So when y squared equals 245,000 divided by 2, and then we just square root both sides, take the positive one, right? Whatever that is, that's our answer. So what's that roughly equal to? This is decimal.
350.
350?
Yeah.
Is it exactly 350?
Yeah.
Okay, so it's exactly, all right. Oops. Ouch. Oh. Okay, so equals 350. Okay, so we get one critical number at y equals 350. So on our domain, there's our critical number. This is 0 of the first derivative. What's the sign of the second derivative? Positive. So by the second derivative test, what do we got here? Which is what we want. If I've only got one minimum on my uninterrupted domain, then it's a global minimum, right? That make sense? So that's our answer, is y equals 350. And then I gotta find x, so I would just plug it back in up here, right? So what's that give us for x then? If I plug in 350 for y, x equals, what is it? 700?
700.
700? Okay, so there are our dimensions. Yeah?
Can you just plug 350 back into the very first primary?
You mean, right, the primary equation?
Yeah.
Well, if I plug 350 in the primary equation, I don't actually know what the perimeter is. I mean, I could find out, right? I could go, if it, by the way, if this asked for what the perimeter is going to be, where would that show up in the table?
P.
Yeah, right there, right. It'd be the dependent variable part of the ordered pair, right? Okay? That make sense? So Emily, in general, where you always want to go, that's why you always put a box around the secondary equation, because if there are two variables, think about what you're actually doing. When you're creating a substitution equation, you've isolated the variable that's going away. The second one you're gonna have to find. Does that make sense? You can always go right back there to evaluate the other variable, okay? All right, so let's talk economics for just a second. Because really, if you look at these, there's kind of two classes of optimization problems that we'll sort of focus on. There's geometric stuff like this. Well, then there's some mathematical stuff. Like we looked at one the other day where we minimized a distance, right? You could do things like that too. But then one thing that I want to introduce you to is just the idea of doing some calculus in economics, because there's a lot of calculus in economics and quantitative economics. And it's, you know, it's not hard stuff. Macroeconomics it's interesting and it's not very difficult. I mean, if you want to be an economist, you ought to be a mathematical economist. Don't be a qualitative economist. That's, if you want to make the big bucks, you got to incorporate the math. So if how do we define if we let, well, what is profit? If P equals profit in macroeconomics, what's our formula for profit? Real simple formula. What's the amount you get to keep?
How much you-
How much you made minus how much it cost.
There we go, okay, good. So it's gonna be how much you made, which is what we call revenue, right? Does that make sense? How much money you're bringing in minus your operating costs, call that C. Okay, so it's profit if we let R equal revenue and C equal costs, like operational costs, then P just equals R minus C, right? So here, let me pull up a sample problem for this. Yeah, this is a good one. I like this one. I can't remember if there's one like this. Actually, let's do it here. There's the popcorn. And there's one I always really like. I don't remember if it's in the online book. I don't want to have to write the whole thing out. Oh man, I have to write this whole problem out. I'm gonna get carpal tunnel. Oh, it's in there, isn't it? Oh, I give up. One last try. Give up. Okay, Well, here it is. Let's try this one. Okay, so let's say, here's the situation. We've got this company, I'm just gonna summarize here. This company has 50 apartment units. When rent is 720 per month, all the units are occupied. Okay, but when each $40 increase in rent causes one unit to become unoccupied. So what we want to know then is, oh, and also, each occupied unit requires an average of $48 per month for service. So the big question is, what rent do you charge to maximize profit, right? Because that's our goal, is to maximize profit. Okay? What are we gonna do about this? $720 per month, all 50 units are occupied.
Increase it by $39.99.
Well, I guess, so you're gonna increase it in $40 increments,
Yeah.
we'll say, right?
Yeah.
If you increase, every time you increase the rent by $40, one unit is vacated, right?
So the rent's vacated, you don't.
So you don't pay the 48 then, you're right. But you're getting less rent from the tenant.
Less.
Well, we'll find out, that doesn't tell us. They'll tell us when we make our table. What are we trying to maximize?
Profit.
Profit. Okay, so our primary equation's gotta be a profit equation. What is the variable here?
Revenue.
Okay, so what do I call it? What we actually call this is, in economics, we call this the demand function. We want to come up with the rate or the cost, right? Okay. So one variable is going to be what we're charging. There's another variable that's going to depend on that, though, and that's the number of units occupied, right? So those two are linked together. Does that make sense? I mean, right now, would you agree we'd have to have a profit function that's gonna incorporate how much we're charging and the number of occupied apartments, okay? But if we could make a connection, and this would be just like our secondary equation here, right? If we could make a connection between the amount we're charging and the number of occupied apartments, that would be good, wouldn't it, right? That would be our secondary equation. So for right now, I'm not even gonna write down what the what the actual, well, I guess we could. So what is profit as a function of those two variables? Let's define those variables. So let's let X equal number of apartments and R equal rent. So what are we gonna end up with then? What's our profit gonna be? What's our revenue gonna be?
RX.
RX,
Mine
right?
was
Does that make sense? Okay, so. That's revenue. Okay, what's our cost?
40X.
48X, okay? Okay, but I've got two variables there, right? X and R. So I need to come up with a relationship, a secondary equation that relates those. Well, where does that come from? How am I gonna relate X to R? Is there some information up there that tells us that
Decreases by
relates to?
one.
Say it again?
Decreases by one each $40.
Oh, each $40, okay, so we know two things then, don't we? We know that we have, for $720 a month, all units are occupied, right? $40 increase, one unit unoccupied. Okay, so this is linear, isn't it? Right? Does that make sense? If we were to think about this in terms of a graph, and that's a good thing to do, let's think about this in terms of a graph. So if, let's say we do this. So, it doesn't matter how about if we put X on this axis and R on this axis? I'll tell you why I'm doing that in just a little bit. Doesn't matter, you can do it either way. What are some points that would show up on this line? What is this first piece of information as an ordered pair?
0,
Is it 0? Because R stands for rent,
What would be 720, 50?
720.50 would be a point, wouldn't it? So I've got 1 point out here somewhere at 720.50. Okay, now what?
Wait, couldn't we,
Oops, let me put on the other side. Okay, what's another point?
760.
760.49. Okay, so I could go over a little bit further, and I'm not gonna draw this to scale, right? So I get a little bigger value for R and a little smaller value for X. Right? And it's just gonna be linear, isn't it? What's the slope?
Negative over X.
So negative
140th?
1/40th, yeah, right? Everybody agree? Because we're gonna drop one, we're gonna rise by -1 apartment for a run of $40, right? So this is just a line. Well, if it's a line, that's a pretty easy thing to relate, isn't it? We're just gonna come up with a linear equation that relates X and R, right? So all we gotta do is take these two data points and do a little algebra 1 on it, right? We just figured out our slope is -1/40th,
40th.
right? So all we gotta do is find B, right? So what's our slope-intercept form of this line? Instead of y equals mx plus b, it's
X equals MR plus.
x equals mr plus b, good. So then we end up with x equals -1/40th times r plus b, and let's just use either one of those points. How about if we use this one as a value of x and r, an ordered pair that we could plug in to solve for b, right? So then what's that give us? If x is 720, r is 50, what's that give us for,
Did you get it right?
oh, I did opposite, yeah,
So-
whoops, got it backwards, that didn't look right. So 50 equals negative 1/40th times 720. So what's B then? Just use your calculator. What's 50 plus 720 divided by 40? That would be, say it again?
68.
68. So that gives us the equation then. We end up with x equals negative 1/40th r plus 68, right? Well, I was dumb about that. I did that backwards, didn't I? Should have done r on the other axis. No big deal. So if we take this equation and we solve, because what do we want to substitute for up here?
R.
We want to substitute for r, don't we? Right? And find out what the number of occupied apartments is going to be. And then I can always push that back into my secondary equation and find out what the rent we're charging is. Does that make sense? Because look, I've got x's there and there, and I've only got one r, so I'd rather solve for r. So let's take this equation and just solve it for r. So if I do that, what do I get? Going to subtract the 68, right?
R equals negative 40x plus 2720.
Okay, good. So we're going to get, I got to add the, what is it again? So I add the 68, subtract the 68, whoops. So I'm going to get x minus 68 equals negative 1/40th r. Multiply both sides by negative 40. And what's that give me?
Negative 40x plus 2,720.
Okay, so
Or
2,720.
2,720.
2,720 minus
40x.
40x equals r. That's a better version of it, isn't it? Right? So now we can make our substitution into there, right? Okay, so then, let me make a copy of that. Okay, so then now we can make our profit as a function of a single variable. So profit as a function of x is going to be x times r, which is that whole thing, right? Minus 48x, right? So what's that give us? 2720 minus 48 is 26, 72? Okay, so there's p of x. Okay, what's our domain? Okay,
So 0 to 50.
then it could equal 0, it'd be kind of dumb.
0
right?
to 50.
To 50, because we only have 50 units. Right, that's important that we get that upper limit on there, because we don't want to, once we get 50, there'd be no sense dropping the price any more than that, right? Unless we're really nice people, but we're not, we're making money here, right? So, what's our derivatives? It's polynomial, it's easy, it's good.
Get 80x plus 262.
So that 2672 minus 80x. And then what's the sign of our second derivative everywhere?
Negative.
Negative. Right, it can be negative 80. So then, when does p prime equal 0? When what?
80x equals 2.
Okay. So what's x roughly equal to then?
33.4.
33.4. Okay. So,
Oh, it's exactly 33.4.
well, it's exactly 33.4.
Yeah.
Okay. So if x is 33.4, then what are we going to probably do here? Because we can't rent a partial unit. So it rounds to 33, doesn't it? Right? This is not a linear function, though. So what should we do to probably be safe? Try both 33 and 34 and see which one gives us a better profit. Right? So let's do that real quick. If you guys practice this little trick, this good little trick. Remember, you could make a table, right? You don't really need to do that, though. Okay, so remember our little trick. We can store a value as x. So let's store 33 as x. 33 store x, hit enter. And then there's our profit function right there. So let's just evaluate that expression. 2672x minus 40x squared is that, 44,616. So now all we have to do is store 34 as x and evaluate the same thing. Let's go grab that expression. So it is going to be 33, right?
$8.
By $8. Okay, so 33 is our answer. Now, but that's really not the question that we're trying to answer, is it? Because we don't have direct control. We have indirect control over the number of apartments rented. We have direct control over what?
How much is?
How much we charge. Aha. Okay, so we'll go back to, there it is right there. There's our revenue, right? 2720 minus 40x. So we'll plug in 33. Oh, man. Plug in 33. Come on. So 2720 minus 40 times 33 means we charge $1,400. That's the optimum rent for us to charge. Okay?
Just about double.
Yeah. Okay. Make sense? Okay. All right.
Then 17 people left.
Yep.